Hi friends, welcome to WebChamp. In this video, I am going to discuss what is a common table expression in SQL. So, if you are preparing for the data analysis or data engineering interview, these questions may comes to you in any of the type. So, what is a common table expression? What is the advantage of using it? When to use? When to avoid? This kind of things you may be able to explain by going through this video. Okay, so CTE is nothing but a temporary result set in SQL that can be referenced within the select, insert, update, and delete statement. Meaning, so whatever we will define as a CTE. So CTE is nothing but temporary result set. Means it is a table that is returned by one of the SQL query. We will store that as a temporary kind of temporary table, but not temp table. Temp table is different. So what will happen when we use CTs? Obviously, it improves the code readability and it makes complex queries more manageable. So we will see the example how this is possible. So there are two types of queries. One CT we use to simplify the complex queries. So meaning wherever you see that there are multiple joins, aggregations, nested queries are used. So it can be breaked into the manageable parts using CT. Then recursive queries. Sometimes we may have a data, hierarchical data or tree structured data. So in that case, like organization hierarchy, CEO, then VP, then director, then senior manager, then team leader, and then rest of the designations are there. So this kind of things, if you wants to find out, so to building the logic in SQL, obviously CTE is going to help us. So now let's see the very first example, that simplifying complex query. So my requirement is pretty much simple. I have to group the data by any category. Okay, you can group the data. Let me show you the table first. So if you come to the databases, I have a database called WebCham. Inside this, I have these many tables. So I would like to pull the data or fetch the data from this sales city. Okay, I'm just trying to create a SQL statement to get the data. Okay, so you can remove this. This is just a limit to fetch the n number of rows. Now here you can see that I have a data for customer. So based on the customer ID, I can find out the how much sales amount or how much amount of purchase that specific customer has done. How to find that? Okay, so simply, obviously, anyone can tell me. The you can use the group by and then use the sales amount, right? Sum of sales amount in that. Okay, so let me do that. Instead of using all specifying all the columns, I will specify star here. So this makes sense. This will give the same result, right? So now instead of this, what I would like to do is I would like to use customer ID, comma, and then sum of sales amount, right? This is my column from this table. So if I specify group by customer ID, so this will give me the result. And this is what we get here. Let me use the alias to say sales by customer. Okay, so now let me format this query and okay, this is what my final statement to get the sales by customer, total sales by customer, right? So now I would like to apply the filter. And how we can apply the filter? Obviously we can apply the filter. There are a couple of ways to do this. So I would like to apply the filter on the sales by customer column. So if I go and if I specify where, okay, then I will say sales by customer is greater than, let's say, 10,000. Okay, so ideally this is not valid. So where should be specified before the group by, right? So let me do that. And okay, so now if I do this, it is not going to verify the column, or it says the invalid column. Why? Because see, if I use this before group by, this column will not be exist. This column will be created after the execution of query. So now how I can handle this? Okay, this statement works well. So either you can use the subquery. So I will put this inside the bracket and then I will say as final rs. Rs is nothing but result set for me. Okay, so alias I used here. So then you should go and query the data from this. So let me say select star from, and this final rs will be my table now. So this is a subquery, right? And here I'm able to sales by customer. I'm able to filter the data. So meaning you should go and use the subquery. You should go and use the subquery. If you use query, because since it do not have the joints and all, so this looks still simpler. But if you have, assume that you have multiple joins and then multiple subqueries, in that case, this expression looks little bit complex, though it is not, but still it looks the one. Subquery has one disadvantage, that subquery in inner query or whatever the query you will consider, that will be executed as many times it needs to be. Okay, so what I want to do is to avoid this, to avoid this, uh, I can use the CTE just to improve the code readability and even improve the performance. So subqueries will get executed many times as they required, but CTE will get executed only once, and that the result of CTE is available until the transaction gets completed. Okay, so we will see, we will discuss more on that in the difference. What is the difference between CTE and subquery query? Okay, so how I can achieve this by using subquery? Okay, so this is the group by statement is remains same. Okay, then what I will do, I will simply say with. With is a keyword that is used to start with the CTE. With CTE, let me say sales. Then I will say as, and then inside a bracket, you can specify the statement, whatever the SQL command you want to execute. And now after this, you can say select star from CTE cells where sales by customer is greater than 10,000. Okay, let me. Okay, it shows still it is running. Okay, fine. Right, let me run. Something maybe bad that's why it took time. But we are getting the same result. But now, if you want to read both the statements, so even here you may feel which is the more readable, right? So CT improve the performance. Once CT is executed, the result of that CT can be used any number of time. But in case of subquery, wherever you will use this, obviously in subquery, what we will do, we will use this statement many times in the your main outer query. So as many times you will use, those many number of times that subquery will get executed. So this definitely this will increase the load on the database. But in case of CT, this is not going to happen. So CT will be executed. This will be executed only once, and then whatever the result will be stored here remains available until all the executions happens. Right. So this is the benefit of CT. So one example we saw that how to simplify the complex queries. Okay, so since joins and all I'm not using here, so you may feel this is a little bit smaller, but yes, in case of multiple joins and other nested queries, you feel CT is more comfortable. Then recursive query. Okay, then recursive query. So when dealing with the hierarchical data or tree structured data, recursive CTs simplify the traversal, meaning the way we write the query is better. So now what I will do is I'll go to this another table and let me select the top just to create this. Okay, let me keep this. Okay, fine. So I have another table here. You will be able to see that there is a one entry where the manager ID is null, meaning obviously we can say that this will be the CEO. I would like to get the data in hierarchical order, that CEO should come first, then the manager ID, obviously. So this should come first, and accordingly, who is reporting to whom, based on that, it should come. So manager ID is nothing but here employee ID. So Alice will be the manager for Bob and Charlie, and then these two will be the dividend. A will be reporting to the Bob. So this hierarchy I would like to find. Okay, so in this scenario, what I can do is I can simply use the recursive CTE. Okay, so now how to use recursive CTE or how to write the recursive CTE, we will see here. Let me keep all these. Employee ID, employee name is fine, manager ID is fine, but I will go and I'll add one more column here as a one as a label. So okay, so this will be column name, so I can use double quote, right? And okay, fine, right. So here what I want to do is I would like to get the first record only, right? I would like to get the first record only. What is different to get the first record? Obviously, manager ID is not there. So I will say where simple statement I used. I am pulling all the columns and I specified where manager ID is null. Okay, this is even we can what we can do is null function we can use here, and then I will say manager ID. Okay, this could be used. Replacement value I don't want to replace. Okay, if it is null. Okay, so this is used for is null is used to handle the null value. So let me say manager ID is null, right? So this will give me the first record only, right? This is fine, and then level we decided as a one, right? So now same thing I would like to do, but but this result I would like to use inside the another query which I am going to use. So before this, what I would like to do is I would like to, meaning this is not the only result, entire result will be stored. Okay, so I will say with CTE employee. Okay, with CTE employee, this is what my name could be anything for the CTE. This is fine. And let me say this is where I started. CTE started. Since CTE started, you should not put the semicolon end the statement, right? And here you can do the logic for your final output. So CTE with CTE underscore employee is my temp table name. I would like to use this one inside my the next query. So what I will do is I would like to get the same, right? So this is just a statement to pull the data from the database where hierarchical label is one. So now I'm going to perform the joins here because I have to check whether the employee ID returned by the first query is a manager ID for next one. So here this is the one, this will give me the one line statement or one row output. I would like to append the remaining tables row to this. So how we can perform the append? Using union all. Okay, it may be a duplicate, but that is fine. So now here obviously everything will come from the employee table, right? So I will say this is emp, right? So let me say emp dot, because I'm going to perform the joins here, right? So emp dot, and here I will say, meaning I would like to use this city. Obviously city is nothing but table, right? This city as another table. So I will say join and city emp as emp lvl emp label on the basis of what you would like to join. So I will say emp dot manager id is equals to sorry, here let's use emplvl dot employee id, right? So now I performed join based on the manager id of the city, sorry, manager id of the employee table and employee id of the city. It's completely fine. But here I would like to increase the level. So how I can do that? So here EMP level. So obviously because this CTE has a level column, I will go and I will add one. This is fine, right? So every time whenever it will go and find the EMP level, it will go and add one to that. And this is going to, meaning this is going to filter the data based on, see, we are just updating the label, we are just updating the hierarchy based on the employee id is equal to manager id. Okay, in CTE you do not need to end this expression. So now let's see star from CTE employee, right? So this is the result. Now let me run this. So you will be able to see the result here. Alice has a level 1, Bob and Charlie has a level 2, right? Why? Because this will get added, level will be added only when it matches the level of the city matches. So this is the example of recursive city ctc, sorry, CTE. So here Bob and Charlie are working at the same, Frank and Grace working at the same level. Then Nancy, Oscar, Kin, and Linda, and Michael and Paul, they all are working at the same level. Then David and Eve are also working with the Frank and Grace, right? So this is how, but this is not sorted. So let's sort this by level, right? So we can use the order by statement. So I will say order by label, and then manager ID. So based on these two columns, I'm going to sort. Now you can see that 3333 is coming four times. Earlier 23 was somewhere in between. Then at fourth level we have many employees, right? So you will be able to identify who is working at the same level and all based on the result what we produced. So this is the a good example of recursive CTE, right? So we saw what is CTE, what is the types of CTE. So simple to simplify the query meaning, and recursive CTE to find out the hierarchical order, right? So now what is the advantage? Obviously it improves the readability. Once you are able to read the data, you will be able to maintain it. So obviously we can say that it improves the maintainability, simplifies the recursive queries. Okay, even what you achieved here with the help of recursive query, you may struggle a lot to achieve that using the normal query, right? Then reusable in single query, alternative to subquery. Obviously this is a great alternative to the subquery. You can avoid using subquery wherever possible. So enhanced debugging and testing, yes, and temporary storage without creating a table. So how this behaving? Meaning CT is going to consume the your database memory or not. So obviously CT creates the table, but it will not consume the memory. So the whatever the table, intermediate table it will create, that will be remains available until the execution get finished. Once the moment the execution finished, CT will be deleted. So this is like a temporary table, but it will not consume any memory. So this is another benefit, or no actual table will be created in the database. But in case of temporary tables, your table will be created in the database, though even that will be available, or that will be remains in the database, but for a short time, even that will be also deleted after the execution done, or transaction done. We can, the session gets expired, so temp tables are also gone. But still, CTE do not consume any memory. It can be used with window functions. CTE can be used with window functions. So these are the advantage. But when not to use the CTE, so when working with a very large data set, CTE is not a good idea. So you are good to go with the temp tables. Use temporary tables if you need to reference the data across multiple queries in a session. Okay, CTE will be available for the same query. It cannot be referenced between multiple queries. So in that case, you should not go and use the CTE. So consider the materialized view if you need to store the result persistently. Okay, so this is these are the scenario where you should not use the CTE. So I hope you like the content of this video. Thank you so much for watching the video. Have a nice day.